so this is our lesson video for section 7.2. And so one thing you're really going to want to use during this section is a periodic table with the charges labeled across the top. Okay, so here's just my makeshift periodic table. Group 1 is +1, group 2 is +2. The transition metals and the lanthanides and actinides are just a positive. They can have variable charges. Group 13 is +3, 14 is positive or -4, 15 is -3, 16 is -2, group 17 is -1, and group 18, the noble gases, have a 0 charge. All right, so hopefully you have that and we're ready to go. So compounds composed of cations and anions are called ionic compounds. That makes sense. Ionic compounds are made of ions. They have to be opposite in charge, so we need a positive and a negative ion. Although they are composed of ions, the overall ionic compound is neutral because those charges cancel out. So the electrostatic forces that hold ions together are called ionic bonds. So what happens is an atom might have an extra electron. So see, its last energy level only has 1, so it's not very stable. It wants to get rid of that extra 1 so that then it can have a full energy level. Because remember, the first energy level only holds 2. It might bump into an atom that has 7 valence electrons, so it only needs 1 more electron to be stable. So what happens is it will give its electron to that atom that needs an electron. Well, once this one loses an electron, it becomes positive. Once this one gains an electron, it becomes negative, and then they're kind of stuck together like magnets. Okay, so that's what happens in an ionic bond. So a chemical formula shows the kinds and numbers of atoms in the smallest representative unit of a substance. A formula unit is the lowest whole number ratio of ions in an ionic compound. So in an ionic compound, like when we say salt is sodium chloride, 1 Na positive and 1 Cl negative. That doesn't mean when you hold a grain of salt, you're only holding 1 sodium ion and 1 chloride ion in your hand. It just means that that's the ratio. For every 1 sodium, there has to be 1 chloride ion. So if you are holding a sample where you have 16 billion sodium ions, there would be 16 billion chloride ions in that same little piece of salt that you have. Okay, so it's just the lowest whole number ratio. It's not necessarily the actual amount. So when you balance charges or cross charges to write the formula for an ionic compound, you must make the positive charge and the negative charge equal by changing the subscripts. The subscripts must be in the lowest whole number ratio to be correct. So the thing is that sometimes when 2 atoms bump into each other, it's not necessarily as simple as the picture I just showed you, where 1 needed to lose 1, 1 needed to gain 1, everybody's happy. Sometimes 1 may need to lose 1, but another one needs to gain 2. So you have to do some, messing around with that. So for example, Pb with a +4 charge and oxygen with a -2. Right now, a +4 and a -2 don't cancel out. Remember, the whole compound has to be neutral overall. So we do something called crossing charges. So you take the number only, not the charge, so not the positive, just the 4, and you cross it down to the oxygen. You take the 2, not the negative, and cross it down to the Pb or the lead. All right, so once you do that, that gives us a 2 and a 4. So let me show you how that cancels real quick. So what is +4 times 2? Well, it's +8. What's -2 times 4? It's -8. So see, a +8 and -8 cancel. So that leaves us with these subscripts, but the problem is it has to be in the lowest ratio possible. Can 2 and 4 be reduced? Yes, it can. It can be reduced to a 1, which is understood, and a 2. Now, you don't have to end up reducing a lot. That only happens in a few circumstances, but just make sure you do reduce if you need to. All right, here's just another example. We have a +2 and a -3. Those, of course, don't cancel. So we bring the 2 only. Notice they did not bring down the positive. We bring down the 3 only. We do not bring down the negative. It's just the number. All right, and so +2 times 3 gives me +6. -3 times 2 gives me -6. So now they cancel out, and so I know my formula would just be Mg 3, and 2. When you're writing the formulas, the subscripts are mandatory. Writing the charges are not. In class, I write the charges so you can follow what I'm doing. A lot of you can't do it in your heads at the beginning of this. So I will always write the charges, but when I'm grading for formulas, the charges are not necessary. So it says, write the formula for compounds formed between the following elements. One important thing is, and you may want to make yourself a note of this, is the positive ion always comes first. Okay, the positive ion always comes first. It doesn't matter what order I give it to you in. The positive one has to come first. Okay, so my first one says potassium and oxygen. So this is where also you need to learn those symbols. Potassium is K, and so I find it on my periodic table. It's in group 1, so it has a positive 1 charge. Oxygen is O. I go to the periodic table, it's in group 16, so it has a negative 2 charge. So I stop and say, okay, do a positive 1 and a negative 2 cancel? No, they don't. So I need to cross my charges. Now notice the 1 is understood. So you don't need to cross an understood 1. All right, I mean you can, but there's no reason to write a 1 down here. Once you see an O, you know you have one of them. So you just cross the numbers. So I take my 2, cross it right here. So see, now I have positive 2, negative 2, and that cancels. And so again, the charges are not necessary. If your answer looks like this, that would be perfectly fine. All right? So let's say the other one, instead of saying magnesium and nitrogen, it said nitrogen and magnesium. This is what I mean by the positive one always comes first. If I wrote nitrogen and magnesium, you would need to make sure to list the positive first. So pretend like it says nitrogen and magnesium. So we would say, okay, nitrogen is in, and I would go over here, it's in group 15, so it has a negative 3 charge. So I would automatically know that one has to go at the end. All right, and then magnesium is Mg. It's in group 2, so it has a positive 2 charge. So do positive 2 and negative 3 cancel? No. So that means I have to cross charges. So remember, cross the number only, not the charge. So see, notice I didn't have a number here, so I didn't cross anything. You don't cross the positive and negative itself, just the number. So I take my 3, cross it here. I take my 2 and cross it here. And now it's positive 6 and negative 6. And so again, if your answer looks like this, like if you can do the crossing charges in your mind and you don't want to write the charges, you're more than welcome to. Technically, the charges don't need to be there. I just write them so that you can see where I'm getting my answer. If I was doing something on my own, like on my own paper or making an answer key for y'all, I'm not going to write the chart. All right, and so see, there's our 2 answers. So maybe pause the video, try these real quick. Remember, make sure you're always listing the positive one first. All right, so I'm going to assume you paused it and tried it, so let's look at them together. So we have potassium and iodine. So potassium is K. It's in group 1, so its charge is positive 1. Iodine is I. It's in group 17, so its charge is negative 1. We'll do a positive and a negative cancel. Yes, they do. So my formula would just be Ki. No subscripts necessary. All right, hopefully you got that one right. Next one is aluminum and oxygen. Aluminum is Al. It's in group 13, so it has a charge of positive 3. Oxygen is O. It's in group 16, so it has a charge of negative 2. So do a positive 3 and negative 2 cancel? No, so I have to cross. So I bring down the 2 only, not the negative. I bring down the 3 only, not the negative. So see, all I did was take my numbers and cross them down. So my answer would be Al2O3. Now keep in mind, you don't have to rewrite your answer. If you turn this in, that's fine. If you turn this in, that's fine. It doesn't matter. Okay, some of you like to keep your charges, some of you don't. All right, next one is calcium and chlorine. Calcium is Ca. It's in group 2, so it has a positive 2 charge. Chlorine is Cl. It's in group 17, so it has a negative 1 charge. So do a positive 2 and negative 1 cancel? No. So remember, I cross the number only. So I'm going to bring my 2 down. There is no number here. It's an understood 1, and I already have an understood 1 down here. So it becomes CaCl2. All right? And last one, be careful on this last one now. Sometimes it throws you off because y'all start getting all cocky because you're like, oh, I know how to cross charges. I remember this from physical science. All right, so barium and sulfur. Barium is Ba. It's in group 2, so it has a positive 2 charge. Sulfur is S. It's in group 16, so it has a negative 2 charge. Do a positive 2 and a negative 2 cancel? Yes, they do, so you don't cross at all. If you ended up with Ba2S2, you got that wrong. Remember, it has to be the lowest whole number ratio. So don't cross if they already cancel. Don't cross. You don't need to. They already cancel. All right, so hopefully you at least got some of those right. So let's move on. So here's our answers that we just determined. So next thing we got to talk about are, oh my gosh, polyatomic ions. So in class, I will have given you a polyatomic ion chart. If you are not in my class, you can find it on my school website, which is linked to my YouTube page, or you can just print one off the internet. So polyatomic ions are just a group of atoms with an overall charge. So right now we've been talking about sodium, Na, with a positive 1, or oxygen, O, with a negative 2. Polyatomic ions could be CO3 with a negative 2. So there's 1 C, there's 3 O's, and all together that group has a negative 2 charge. When you balance charges for polyatomic ions, you follow the same rule of crossing and trying to cancel your positives and negatives. However, if you need to add a subscript to a polyatomic ion, then you have to put the polyatomic ion in parentheses. So for example, if we're doing calcium, which is Ca, it's in group 2, so it has a positive 2 charge. And say we are going to bond it with nitrate. So nitrate will be on your polyatomic ion sheet is NO3 with a negative 1. So don't start freaking out and thinking, oh my God, what do I do? Okay, just cover this up if it's stressing you out. We have a positive 2 and a negative 1. That doesn't cancel, so I need to cross my 2 down. Well, because it's a polyatomic ion, I just put the whole thing in parentheses and then put my 2. And so see, then you have positive 2, negative 2, just like that. All right, that's the only difference. Polyatomic ions, for some reason, are the devil. I don't know why. I mean, it doesn't make anything more difficult, but some of y'all, you can do things in chemistry, and then if I throw a polyatomic ion in there, it's like you can't do it anymore. All right, so let's get some practice on polyatomic ions. So you really need your polyatomic ion chart so that you can see what the formulas are for these things. All right, so we have sodium and phosphate. So sodium is Na. It is in group 1, so it has a positive 1 charge. Phosphate is on your polyatomic ion sheet. It's PO4, negative 3. All right, so again, if you're confused, just cover up the PO4. So we have a positive 1 and a negative 3. Does that cancel? No. So what do? We cross our 3 down. And there you go. So your answer would just be Na3, PO4. Because see, now we have positive 3 and negative 3. All right, so let's move on to our next one, ammonium nitrate. Ammonium is on your polyatomic ion sheet. Ammonium is NH4, positive 1. Nitride, a lot of you go to that polyatomic ion sheet and you either pull NO2 or NO3. Nitride is not on the polyatomic ion sheet. Remember, if it ends in "ide," it's just the regular element. So that's just nitrogen when it's negative. So nitrogen is N. It's in group 15, so it has a negative 3 charge. Okay, so again, don't stress out. Cover this up. We have a positive 1 and a negative 3. They don't cancel. I need to cross my 3 down. Well, since I'm crossing a 3 down to a polyatomic ion, I just put it in parentheses and then put my 3. So I get NH4 3N, just like that. All right, a lot of people, they start asking in class, well, does the charge go in or out of the parentheses? Well, remember, the charge technically isn't there. So in class, I don't sit there and try to force it in or outside of the parentheses. Like this time, you can see the parentheses just go straight through it, because I know that at the end, we don't really have the charge there anymore. All right, and so last one is aluminum carbonate. So aluminum is Al. It's in group 13, so it has a charge of positive 3. Carbonate is on your polyatomic ion sheet. It is CO3 with a negative 2 charge. So I need to cross my charges because they don't cancel. Positive 3, negative 2 don't cancel. I need to bring my 2 down, And then I need to bring my 3 down. Now some of you may think, oh, it already has a 3, I don't have to do anything. You still have to bring it down. But how do I bring a subscript to a polyatomic ion? I put it in parentheses and then put my 3. So see, now I have positive 6 and negative 6. So it's Al2, parentheses, CO3, parentheses, 3. All right, so like I said, polyatomic ions are not going to go away. So you might as well go ahead and get used to using them and understanding them. That makes the rest of your life easier. All right, and there's our 3 answers. So you try these 3 real quick. Again, if you need to look up the polyatomic ions online, if you don't have your chart, that's fine. So I'm going to assume you paused the video and tried them, so let's look at them together. So we have barium nitrate. Barium is Ba. It's in group 2, so it has a positive 2 charge. Nitrate is on your polyatomic ion sheet, is NO3 with a negative 1 charge. So I need to cross my 2 down. How do I do that on a polyatomic ion? I put it in parentheses. I have one class one here who said they parenthesize it. So we just turned it into our own verb. I'm all for making up words, as long as it's not, chemistry related word. All right, and so your answer would just be Ba, NO3, 2. All right, next one is lithium phosphate. Hopefully you got that one right. So let's see if you got this one right. Lithium is Li. It's in group 1, so it has a positive 1 charge. Phosphate is on your polyatomic ion sheet. It's PO4 with a negative 3 charge. And so positive 1 and negative 3 don't cancel out. So I need to cross my 3 down. I don't need to cross anything down to PO4, so I don't need parentheses for it. However, if you put parentheses when you don't need them, it does not make it wrong. I have some students who they want to put parentheses on a polyatomic ion every single time they write it, and that's fine. All right, so hopefully you got that one right. So let's look at our last one. This one's a little bit tricky because, again, some of y'all, you start getting real good at crossing charges, and then you cross when you don't need to. So we have strontium sulfite. So strontium is Sr. It's in group 2, so it has a positive 2 charge. Sulfite is on your polyatomic ion sheet. It's SO3, negative 2. So do positive 2 and negative 2 cancel? Yes, they do. So I don't need to cross. Remember, we only cross to make the charges cancel out and balance. If they already cancel, we don't need to cross because otherwise we're not at the lowest whole number ratio. All right, so hopefully you at least got a couple of those right, if not all 3. In my class, we'll do way more practice on this than you'll ever want. But by the end of it, you're going to know how to do it. All right, so let's wrap up with some properties of ionic compounds. So an ionic compound, an example is salt. So you can just think of salt when we're thinking of this. So properties of ionic compounds include the following. They tend to be crystalline solids. Well, think about a salt, a little salt crystal. It's solid, like you don't get liquid salt or gaseous salt usually. They tend to have really high melting points. So can we melt salt if we want to? Yes, you can melt it, but it melts at a very high temperature. They conduct electricity when molten or aqueous. Molten means when we melt it. Aqueous means when we dissolve it in water. There's a difference in melting salt and making salt water. So solid salt cannot conduct electricity because the ions are locked in place. They're in those fixed positions and they're vibrating in those fixed locations. But if you melt it or dissolve it in water, the ions are free to move and then it can conduct electricity. Because they are made of cations and anions, that means it's normally a metal and a nonmetal. Because remember, the metals tend to be the positives, the nonmetals tend to be the negatives. So you have a positive and a negative, you have a metal and a nonmetal. You can't have 2 negatives bond together ionically because they would repel one another. And then, of course, they're made of ionic bonds. Another type of bond that we'll learn about is covalent. Another type of bond that we'll learn about in this chapter is metallic in the next section. All right, and so then here's just a picture again of how an ionic bond is working. Okay, and of course I've started talking about it in the middle of it, so let me let it kind of restart. All right, so in this picture we have a sodium atom with 1 extra valence electron and fluorine atom who needs 1. Sodium gives its extra electron to fluorine. Now they're both stable, but sodium has become positive, fluorine has become negative, and that's what's holding them together through their ionic bonds. All right, so crystals crystals, a crystal is a substance with a 3D repeating arrangement of particles called the crystal lattice. The coordination number of an ion is the number of ions of opposite charge that surround an ion in a crystal. I know that gets kind of wordy. So what that means is if I have a sodium chloride crystal, if I want to know coordination number, if I find a sodium ion, the coordination number is how many chloride ions are around that. Now you do have to focus on the fact that this is 3D, okay, because a lot of people, they'll say, oh, well, it's 4. Okay, it's not 4 because it's 3D. There's actually one chloride behind it, and there would be one in front of it too. But we don't have to figure out how to calculate coordination number in here. It's just a definition for us. All right, so let's knock out this section assessment. How can you describe the electrical charge of an ionic compound? Well, remember, even though an ionic compound is made of positive and negative ions, overall the whole compound is neutral. Okay, that's the whole reason that we cross or balance the charges, is because the whole compound itself has to be neutral. So what properties characterize ionic compounds? Okay, well, we just discussed a whole bunch on one of our previous slides, so let's just pick 3. We can say that they are made of ionic bonds. They are crystalline solids. And they have high melting points. You could pull any of them from that previous slide, but I just pulled 3 off the top of my head. All right, so number 3, write the correct chemical formula for the compounds formed by each pair of ions. Okay, so they gave us the ions, and then they were nice enough to give us the charges. In class, I would expect you to be able to find the charge from the periodic table. Okay, so we just need to decide, do the charges cancel? So we have K positive 1, S negative 2. Those don't cancel, so I would cross my 2 down, so it would be K2S. All right, here we have Ca positive 2, O negative 2, positive 2, and negative 2 cancel, so I don't need to cross. That's one of the most common mistakes, is some of y'all, you get so good at crossing and you get so fast at it, and then you feel really comfortable with it because you understand how to do it, that you cross when you don't need to. All right, next one is Na, sodium with a positive 1, oxygen with a negative 2, oxide ion. So we need to cross our 2 down, so it becomes Na2O. And then last one, we have Al with a positive 3 and N with a negative 3. Positive 3 and negative 3 already cancel, so it's just ALN, just like that. All right, so hopefully, again, you're getting good at crossing charges. Again, in my class, you will have so much practice, you'll never want to do it again, but we will be doing it a lot the rest of this year. All right, so it says write the formulas for each compound. So it says barium chloride. Well, barium is Ba. It is in group 2, so it has a positive 2 charge. Chloride is Cl. It's in group 17, so it has a negative 1 charge. So how do I balance these? Because plus 2 and negative 1 don't cancel. I cross down my 2. All right, to save time, I'm not going to keep rewriting it. All right, next one is magnesium oxide. So magnesium's Mg. It's in group 2, so it has a positive 2 charge. Oxide is just oxygen. It's in group 16, so it has a negative 2 charge. So positive 2 and negative 2, they already cancel, so I don't need to cross anything. It's just MgO. All right, lithium oxide. Lithium is Li with a positive 1 charge because it's in group 1. Oxide is O. We already decided it was negative 2 because it's in group 16. I have positive 1 and negative 2, so I need to cross my 2 down. So it becomes Li2O. All right, and last one, calcium fluoride. So calcium Ca, it's in group 2, so it has a positive 2 charge. Fluoride is F, it's in group 17, so it has a negative 1 charge. Positive 2 and negative 1 don't cancel, so I bring down my 2. All right, and again, the sooner you get really good at doing this, the easier your life is going to be in this class. Chemistry is really not that hard if you'll fully understand the topics as we go. So then by the time we get to something super awesome like stoichiometry, you're not pulling your hair out because you don't even know what the symbols on the periodic table are, and you don't know what the charges are, and you don't know what an electron is. Okay, if you'll just learn the stuff as we go, it's really not that bad. All right, so number 5, which pairs of elements are likely to form ionic compounds? Remember, an ionic compound is made of a positive and a negative. You gotta have metal and non-metal, positive and negative. 2 positives will repel, 2 negatives will repel. All right, so let's look at our charges. So Cl is in group 17, so it has a -1 charge. Br is also in group 17, so it has a -1 charge. So will 2 negatives bond ionically? No. So A is not going to form. All right, next one. We have Li, which is in group 1, so it has a +1 charge. Cl is in group 17, so it has a -1 charge. So will a positive and a negative bond? Yes, they will. All right, part C. K is in group 1, so it has a +1 charge. Helium is a noble gas. That means it has a 0 charge. Noble gases do not like to form compounds because they are already stable. So this would not form an ionic compound. All right, and then last one, part D, I is in group 17, so it's -1. Sodium is in group 1, so it's a +1, so this would form an ionic compound. However, I do want to point out, if we were writing the formula, which one has to come first? The positive. So if it told me to write the formula for this, I would say, okay, Na positive, I negative, and I don't need to cross, so it would be NaI. If you put I-Na, that would be wrong, because the positive one has to come first. So see, this is what I'm talking about. Just because it's not given in the correct order to you, you have to know that the positive one always comes first. All right, so that's it for section 2. So get practicing on crossing those charts.